Hello everyone, my name is Deng, and today I'm going to be sharing with you my senior Honors Academy project, which is entitled C.A.D. So let's begin. So as Earl Nightingale once said, everything begins with an idea. Now, where did my idea come from? So my idea actually stems from when I was a little kid. At the Allen County Public Libraries, they opened up the 3D printing maker labs when I was very little, and my dad used to always point them out and make jokes about how, oh, you'd be like the coolest kid if you could like go in these labs, make something, print it, bring it out to school. I actually had a couple of friends do that with like the Minecraft pickaxes and the Minecraft swords, and everybody thought those were super cool. And I really just never got into it because I one, never had the time, and two, I just really didn't feel like doing it. But I never really got into the whole designing portion. So a big part of why I was so interested in that is that because when I was young, I was always curious. I always wanted to learn more. And of course, when you're little and you see someone else doing something that's interesting or different, you think it's way cooler than whatever you're doing. So back when I was little, I used to just watch YouTube, play video games, and then all my friends were making these cool like Minecraft pickaxes that I was like seeing on YouTube in real life, and I was like, oh my gosh, that's so cool. Moving on, a quote that I really like is as follows: "The process is the most important part of the journey. Appreciate it while you have it." So we're gonna start talking about my process. So to begin, I want to introduce my mentor, who helped me throughout this entire thing, kind of keep me on the right track. My mentor is Dr. Yanfei Liu. She's an associate professor of electrical and computer engineering. So she's basically helped me make sure my designs in the program make sense, help me basically create a game plan, and just help me throughout the entire project, making sure I'm on track. So, first step. Well, I gotta figure out what I'm actually gonna do. So I gotta determine a game plan. Which software should I use? There's three main ones that I'm looking at. It was Fusion 360 from Autodesk, AutoCAD, and then also Dassault Systems SolidWorks. So in the end, I've eventually decided on SolidWorks because it's going to stick with me a little bit longer if I decide to pursue any project in the future, because it has a little bit more sophistication compared to Fusion 360 and AutoCAD. As I said, SolidWorks is a lot better at more sophisticated 3D models and simulations, which I actually haven't used yet, but if I do plan on using it in the future, I'm sure that it would come in handy. Also, I prefer working on a Windows platform compared to Mac, because MacBooks tend to have less RAM and less computing power on average, because they're limited a little bit by the software. And the last reason is that Dr. Liu had a license for it, so it was probably the easiest one that I could have gotten. The only downside that I could see by using SolidWorks is that I actually can't view the files on another platform, so I can only view them on Windows with SolidWorks installed because it has a specific .solidworks file name. The next step. After choosing a software, I have to first learn the software before I can start using it. So how did I learn the software? YouTube. YouTube was a really big help. Lots of good videos and a lot of tutorials that kind of walk you through everything. And I've actually got a video right here that kind of explains a little bit about the software. So after learning the software, I need to get more familiar with it. So the first project I did is this phone stand. So on the left, you can see the CAD model of it, which is just gray. You can add colors, but I did not because it simplifies it a lot more just to leave it as is and then do all the rest of it later. On the right, you can see the actual printed object. So this was originally designed as a double-decker wireless charger pad where you can have one charger on top and one charger on bottom. Right now I mainly use it for, as you can see in the picture, I use it for my AirPods. I also use it for my phone. Sometimes I'll have my parents come in and just place their phone on the pad. They need a charge and they don't want to plug it into the wall. So one of the problems with this one is I didn't design it high enough. So the bottom section is actually really hard to get into. So at the moment, I'm just using it as a pen storage, kind of, as you can see in the picture. But if I do eventually decide to reprint it, I would definitely redesign it so it's a little bit taller and it's a little bit wider, because at the moment it is a little bit tight. So one of the main points while doing this first project was to figure out how to draw sketches, which is the 2D models, and then how to create 3D objects from that 2D sketch. So by cutting and extruding, which is pulling out objects from the 2D sketch, you can create these 3D objects, which you can then 3D print with using PLA plastic and make these really cool objects. Next, I'm still getting used to the software a little bit. Decided to start a second project, which actually decided to be a phone stand. It's currently in the not constructed phase because of a few issues that I'll talk about in a little bit. But with this second project, I was really trying to make it a lot more complex than the first one, because the first one was just one sketch, one extrusion, and like one cut. With this second one, my main goal was to start using the SolidWorks assembly function, which allows you to put multiple parts and mate them together, which means you can push them together and so they're always stuck together. The final end result was a phone clamp, which you can kind of see here. You've got the clamp on the bottom, which will connect to the table, and you've got the phone grabber, which actually requires a rubber band on the back to hold it together. On this next slide, you can see that there's a couple more parts. This is actually the actual phone holder portion of the clamp. And this part actually took me quite a bit because I used a tutorial on this, but I just decided to change quite a few things actually. And they didn't work a lot of the times. And one of the reasons is I didn't measure first and I just did stuff. So I mean, one thing that I really learned during this process of making this specific project is that you should always measure first and make sure everything will fit together before you start doing and creating the actual product. So the next step is actually to begin work on what my original project idea was, which was to create a drone in SolidWorks, print it out, and then make it fly. So with this drone, it was a total of 14 parts, which includes but is not limited to body and arm parts, propeller guards, the actual propeller blades, and then the frame, which would sit the flight controller, which is like the middle part. So I actually had a lot more iterations of these projects that are on the screen right now, but it would take at least 5 slides, and it's quite a few pictures of this the same thing with very minute tweaks. So each iteration really just fixed those small concerns. Like one of the concerns was for the propeller guards, which you can see on the screen. They were the connection points from the outer ring to the inner ring were too thin. So when you would put them together, they would actually be at risk of breaking apart because the plastic is actually quite brittle. Another problem was that the blades originally were 1mm, and those are too thin to print successfully and with any sort of structural rigidity. And the last problem is that I had to add a little extra bit on the bottom of the blades to ensure proper printing, because 3D printers print in layers like this, and then the blade is actually at a slant. So you're printing on this side, but you have nothing to print on top of on this side. So you have to add a little support right here, which will allow you to have a little bit more stable platform to print on. So the entire product ended up being about 16.5 hours. Lots of redesigns happened and a lot of table punching occurred. I'm really actually surprised that my table, which is right here, is not broken, because I did punch it quite hard quite a few times. The original design I found on Google and downloaded, but there's a lot of things I wanted to change, like the blades, the propeller guard, the arms, which I had to change to fit the guards, and then a few unnecessary parts that weren't needed. Like there was one little spinner part that was basically included inside the motor that I bought. I wouldn't have needed the spinner because of the motor. The redesigns almost never worked. The first time. It took like 3-4 redesigns. Basically throughout this entire process, I learned about what a good design choice was and what a good design was versus a good, in my head at least, a good but impractical idea that would be really hard to implement, such as the 1mm blades. So the next step is actually to start flying the drone and not crashing. But if you notice on the screen, it is actually different from what you see in the C.A.D files. So this is because the printed version of the drone had a few structural problems. One of them was that the parts weren't as strong as we were hoping, and the other thing is that it was way too small. So like the drone on the screen is about 2 feet by 2 feet, but the one that we printed was maybe about 1/2 foot by 1/2 foot. And so the problem with that is the battery would have been too big to place on the actual printed frame. So this frame actually comes off of Amazon. I bought the frame on Amazon because it would have taken too long to scale up all the parts and make sure the printer printed them right every single time, which was a lot of hassle, and both me and my mentor decided that it would be better to just go on Amazon and buy the frame. We also bought all the motors, batteries, all the things that you can't physically build by yourself on Amazon, and then we put them all together on top of the frame. So a few of the requirements that I noticed for putting a drone together is I have to be able to have basic knowledge of some circuits and also how to solder and how to write some complex code. But I don't know how to do a lot of that. So with the circuits, I learned a little bit about basic knowledge. Soldering, I didn't get to learn. Dr. Liu actually had one of her students come and help me with that. The code I actually just found off of Google, and I changed the different values that I needed to change to ensure the drone was balanced. So a lot of the parts that are required for putting this new drone together, the frame, which I bought off of Amazon, motors, the ESC, which is an electronic speed controller, which controls the speed of the motors, a gyroscope to control the balancing of the drone, left, right, front, back, and yaw, which is turning on one plane, a barometer, which was used to measure the pressure underneath, which could calculate altitude, wires to link everything up, an Arduino Nano, which would end up being a flight controller and what the code was for, and then also a radio transmitter and receiver, which is basically a remote control. So moving back to our flying the drone step, in order to fly, the circuit board needs to actually be programmed to quote-unquote talk with the ESC, the antenna, the gyroscope, and the barometer. So these four all work together to ensure the drone flies properly. We also had to change a few PID values in the PID controller, which stands for Proportional Integral Derivative Controller. It's basically a control loop that reads data from all of these different parts and then adjusts motor speed to reflect the desired outcome, which in our case is a flat and level drone, so that it will not just pitch forward and pitch back and just crash into a wall. Now, moving on to a few reflections. As Anurag Prakash Ray once said, good times become good memories, and bad times become good lessons in life. Some good things. I learned a bunch. That's one of the big things. I learned a lot about the process of designing a product and the things that might go into it. I learned about the basic parts for a drone. I've always wanted to build a drone. I've always been interested in seeing how, and interested in trying to make some cool drone shots myself. I also learned a little bit about basic circuit board and wiring knowledge. And also, I really just learned how to fly a drone, even though I'm pretty bad at it. And I have a few pictures to prove that in a little bit. A few challenges that I faced. It required some skills I didn't have, like writing and editing some complex code. The Arduino code was very, very complex, and I've never seen anything like it. And a lot of it was just Google. The code actually had very good notes on the side, which was very helpful as well. I also didn't know how to solder, so like I said earlier, Dr. Liu had one of her students come and help me with that. So it wasn't too big of a deal, but I still don't know how to solder, which is something I would want to learn in the future. I also learned a little bit about Arduino Nano and the different connector pins and connection points and what those might do, like the different connection points like the ground, the +5V, all that kind of stuff. So here on this screen right now is my proof of why I am probably not supposed to be flying a drone in public areas where there's lots of people. So if you, the first time I crashed, it was into a wall due to a little bit of connection lag between the controller and receiver. Thankfully, only the blades broke that time, so it wasn't too hard of a fix. I just had to find the spare parts. The second time, which you can see on the screen right now, I landed really hard and then crashed into a wall. So after that, I saw smoke coming from a wire, which you can see on the left picture. You can see that it is burnt and very brown. I also broke a solder point, which you can see on the right, where I'm holding it in the picture. That solder point actually broke off. And then also in the middle picture, you can see that I broke one blade pretty much cleanly in half, mainly because I'm just an idiot at flying and I don't know what I'm doing. But that's not the point. I did break that. It was a very easy fix. I just had to change the set of blades. So a few unexpected items that I came across were parts shrinking, a lot of code errors, design errors in SolidWorks, and then a lot of latency in SolidWorks. So with the shrinking, the parts after printing would all shrink and they wouldn't fit together. So like if I had a part here and a part here that was supposed to fit into, and these wouldn't fit into each other. They were just too small or too large, which was a big problem because if you can't put them together, then you don't really have a final product. Code errors took a lot of time to find and fix, similar to like bugs in computer code. A lot of just head scratching and looking for a problem that might not even exist where you think it is. Latency is probably a result of computer specs. My PC was probably not completely up to the task, considering it is a little bit on the older side. And then in addition to that, the picture quality on the SolidWorks on my PC wasn't the best it could have been, which again, I'm just going to attribute to computer specs, which is the graphic card. And so, my final quote: never stop learning because life never stops teaching. So now we are going to go through a little demonstration of the drone through a couple of videos that I had when I was testing it. So what have I learned throughout this entire process? So I learned the basic process of design and implementation. I learned that troubleshooting is tedious and I do not have the patience for it. I learned about some basics with the SolidWorks program and some basic knowledge about circuits and circuit boards. I also learned that I should draw designs on paper and keep ideas there, which is easier to implement because they're all on paper for you to see, rather than having them floating around your head and then you might forget them. Also, I realized that taking inspiration from the internet, which is a great tool, is very important because a lot of people might have cool ideas that you never would have thought of. And finally, I would like to give a huge shout out to my mentor, Dr. Liu. her student, Ting Yuo, who helped me with a lot of the soldering and actually putting the drone together because he had actually created one before that he knew what to do with. I'd also like to thank my family for everything they've done to kind of help me along, support me with that. And I would also like to thank Google and YouTube especially, because without those web browsers and websites, I don't think I would have been able to do any of this project, especially learn the software and also the different aspects and parts that go into building a drone. Alright, so thank you for watching. If you have any questions, you can always contact me on Instagram, which I have left on the screen. Thank you very much for watching, and I hope you have a great day.